Now we will solve problems revolving a region about different lines. It may be axes or at specific lines. Here we have a problem where R be the region bounded by y equals 4 minus x square and y equals 0. Find the volume of the solids obtained by revolving R about each of the following axes, that is, the y-axis for the first problem. Here, first we need to sketch the graphs. We have already sketched the graph of this previously. Over here, it's a parabola. Now, they have not restricted any limits, so you have to just draw a parabola opening downwards. But y equals 0, this line, okay, where y is 0 over here, that's the limit. So, next thing is you're rotating around y-axis, so that means it will be this. But since they have not restricted anyways, you got this. But let's see what's the radius. The radius is this line over here. So write the equation in terms of y because we are rotating around y-axis. So get everything to the other side and x to one side and you got this over here. How would you know the limits now? Limits are along 0 and 4. See, y is 0, that is fine, but how would you find the 4? Either from the graph because this is the intercept, or you can substitute this as 0 and solve. Square on both the sides, this is 0 equals 4 minus y, that is y equals 4. So that would be the limit. So it's 0 to 4. Now we have this figure. Now all you need to do is substitute the values. We have the limits, we have the equation, substitute it over here. Because we found the equation of x, okay, equals root of 4 minus y, that is square, and over here pi, and 0 to 4. And this is the answer, that is 25.13 unit cube. It's very simple. It is not a washer problem. It is a simple disk problem. This is the disk formula. Now we will see over here the line y equals minus 3. This is very crucial because previously we had solved a problem where we had been given the equation like this and they are told to rotate along y equals 2 or something like this. So what we did the upper equation 2 minus this equation, whatever the equation was over here. It was, I think, 1/4 of x square. And then this line was something 2 minus 1. So the line was upside. So this line minus the below equations. But now look over here. When we graph that, we just now did it, right? We saw the graph over here. But you're revolving below minus 3. So this will be the equation. See, this is the hollow region. We just need the solid part. It's like a washer now. What can you do? It's very simple. You need to write the radii, right? Remember now in this case, what is the radii? What is this equation? This is 4. Upper equation is 4 minus x squared. You need to subtract this line. See this line, what is this? Minus 3. It eventually becomes 4 minus x squared plus 3. This is the thing. This is important to know. Okay. There are other ways to find the radius, but this is a simpler way. So this equation is stopped. So you're rotating along this axis. So this equation minus this point will give you the outer radius. Now same way for the inner radius. So now what we have done is 4 plus 3 will see over here. After simplifying, 4 plus 3 is 7 minus x squared. Same thing for the inner radius. Now over here, this line, what is this line at? It's y is equal to 0. So it is 0 minus, what is this line at? Minus 3. Okay. So it is 3. Radius is 3 for the sorry, this is the inner radius. The first one, capital R, is outer radius. I'm so sorry for that. Outer radius and the inner radius is 3. Now, how do we find the limits? This is along which axis? Y axis. Sorry, along x axis. I mean, see, it is not along x axis. It is along the line y equals minus 3. Where is the line y equals minus 3? It's over here, right? Minus 3, it's straight. Now, you're revolving similar to the x-axis, right? So everything in terms of x. So it's fine. Now this is it. These are the equations. But make sure to find the points of intersection in the graph. You can easily find it if you know exact plotting of graph. But what if you don't plot this graph exactly? You did a rough sketch. Then just equate these two equations. Equate it. So you will find where this line and this equation will touch. That's it. So how do you do it? 4 minus x squared. You can take this x squared to the other side. It is 4 equals x squared. Square root of 4 is plus or minus 2. So the limit will be from minus 2 to plus 2. That is the limit. Now use the formula and solve. The formula is from A to B. Capital R is the outer radius minus the inner radius. The limits we found was minus 2 to 2, 7 minus x squared the whole square, minus 3 squared. Put this in the calculator, you will find it. You can press S and D and you will get the unit. Unit cube is the units. It's 98.13 unit cube because it is volume. So this is very crucial to know which line it is passing by or which axis is it passing by. If it is along the y-axis, you must get all the terms in terms of y. So it will be x is equal to everything in terms of y. Whereas if it's along the x-axis or it's a vertical, see along any vertical line like this is a vertical line, right? Then you have to get all in terms of x. The derivative will be with respect to x.